So there is one other kind of manometer that we do want to talk about, and that's an inclined tube manometer. Now, when we compare this to the U-tube manometer, it's just slightly different. So what happens and why this exists is when we want to have a little more graduation in our measurements. We want to be able to measure smaller pressure differences. And as you can see from this picture here, this looks like a U-tube manometer, except this section right here is bent. And so by bending it, what that does is as the fluid moves up and down, you are able to get smaller measurements because it's traveling along this longer line. Now, solving this is absolutely no different than a regular manometer. So as we take a look at it, it's the exact same thing. We look at here, fluid at the same depth. We'll call that 0.3 since there's a 0.2. Pressure at 0.1 is equal to pressure at 0.3 because they're at the same depth. It doesn't matter what the linear spacing is, it only matters the depth. So as we look at this now, what we have is, you see, we have this length from 0.2 to 0.3, and so this length is what you measure off of. So how do we go about solving one of these manometers as opposed to the regular U-tube that we dealt with? Well, all we have to do is we have to figure out what the distance between, the vertical distance between 2 and 3 is, because that is going to be our height measurement. And so we just take a look at it and we do trig. So we have that in this picture here. We have L2. That's the length of our manometer. And so what's that going to be? Well, that's just going to be h, the distance from 1 to 2. So h divided by the sine of the angle of how we have this tilted. And so we just go and we plug this back into our normal equations and we just solve it that way. So it's like if this was at a 90-degree angle, the sine of 90 is 1, so theta equals 90 degrees, L is going to be equal to h. Of course, then if we go and we tilt this, say angle is 30 degrees, and we tilt that down, well, we're going to end up with L is going to end up being twice h, because sine of 30 will be a half. And one last one, let's say it's at 45 degrees, so L is going to be 1.41 times h. And so we just go and we can solve this. Now, I've got it written in terms of L for our equation. You might want to rewrite this and go, well, h is L sine theta. And that will give you the depth that you're at. And you just calculate it, solve it the exact same way as the U-tube.